Welcome to part 4, Competency 10. In this video, we will work with three-dimensional shapes. Number 1, find the total surface area of a cylinder with a radius of 3.5 centimeters and a height of 12. Okay, if we flatten this guy out, any cylinder, we know we have the part that wraps around the can. And then we have the bottom and top, which are circles. So what do we put in our calculator? Okay. So if you look at your formula sheet, you know the area of a circle. So 2 and in parentheses, now I'm going to do something strange. Actually, let me write it out for you first. Watch this. Let me change colors here. We need 2 pi times pi r squared because that's circles. Then plus this rectangle that wraps around. That's 2 pi r h. Okay? Factor out the pi. What does that actually give us in the calculator? 2 times 3.5 squared plus 2 times 3.5 times 12. Pi will be hanging out. We will not enter pi in the calculator. Hang on. I wrote that for a reason I was going to highlight. There we go. Because I'm highlighting, they're actually using it as a variable because it is in terms of pi. Okay, so okay, I started putting that in the calculator, but let's not do it like that. We need pi to hang out. So 2 times 3.5 squared, then add 2 times the 3.5, then times the 12, and there we go, 108. Put the pi back on, and that would be option A. Okay, quickly, let me show you in the calculator. If we say times pi and enter, you will get this decimal. If you worked it out by hand on your own, and this is a decimal you got, anytime this happens to you, just out of curiosity, and you see your ABCD options in pi, just divide by pi. Divide by pi, you will go back to what you need, okay? All right, it can work for you. It's not too tough, all right? Okay, so let's go on to number 2. Find the volume of a standard rectangular cone with a radius of 7. So here's my 7. And a slant height of square root of 130. Okay. It's very common to see that. But what we really need, that's the wrong height. It's not the height we need. What we need is this right angled height right here. That's the culprit that we need. Well, when we solve that Pythagorean theorem that's created there, not a problem, that right triangle, and that's what we're going to apply. So let's clear out what we have here, and let's put that in and under the radical. Now, what are we really putting under the radical? We already have a square root. Not a problem. I'm going to go through the whole process. You probably already see what would happen. So I'm going to say second radical, parentheses. I'm going to use another square root, 130, arrow over, close my parentheses, and square that. Now, you're probably saying, you don't have to do that. When you square root, it just becomes a number itself. Well, I'm trying to teach you, so you see it. But play around with it different ways. You're more than welcome. It's your test. You do things the way you know you need to. Then you need to subtract this radius of 7 squared. Okay? Now, let's push enter. And we have 9. So we know that this is a height of 9. So now let's put what we need in our calculator, but be careful. We actually have we need to have the volume of the cylinder divided by 3. Well, that is pi r squared times height. Well, I need, again, pi to hang out on the end because that's what's happening here. It uses the variable again. Well, I'm going to let it hang out. Then I'm going to say my radius squared times my height of 9. what am I putting in the calculator? What I have in parentheses, okay? So fraction 7 squared times 9, go down, divide by 3, and there we go, 147, option B. Okay, that's just a quick way to do it without worrying about pi. Now, if you included pi, like I said, just go divide by pi, and then you'll see the coefficient of 147 that you needed. Okay, all right, let's go to number 3. All right. Find the height h of a cylinder whose radius is 6 centimeters and a volume of 108. Okay, well, let's see. What do we have to do? Well, we know the volume is 108, right? And pi, with pi, 108 pi. And that equals, okay, any cylinder, okay, that's going to be pi r squared times height. Okay, so we have pi and we have r squared, which is 6, times h, I don't know. Okay, so let's divide both sides by pi, 6 squared, and I'm going to put 6 squared here and pi here. Now, you probably see a theme going on here, but let's just pop this in the calculator. But what do we not need? Well, we do not need pi. That cancels, that cancels. You can put it in if you like, doesn't matter. I'm going to put it in, okay? 108 with pi, and then go down 6 squared, and type in your pi, push enter, and your value is a height of 3. Now, double check that, okay? I also want to show you that you could do this, okay? Notice when I first set it up and I said it was equal, you could, knowing that you're looking for H, I'm going to say second mode to clear out. I'm going to go to table, clear everything out. I'm going to use my highlighter here. I could look at this. Well, if both sides are pi, I could have put in 6 squared x, okay? Push enter. Now notice I didn't put pi in. Why did I not put pi in? Because the truth is I only need to see when it equals 108. I'm going to go 0, and I'm going to go down, push 1, and I have it in ask mode. Go down, push enter, and you can delete everything out. And this is just a good way for me to check. So I'm looking for 108 because that would be the total value they gave me, okay? And I'm letting pi hang out on the end, okay? All right. So first I'm going to see if 3 is a good answer. Yes, I get 108. Let's try 5. Nope. That's 180. Let's try 7. No. And then I'm going to type over 9. See how it'll type over 9? And again, it doesn't work. So that's a good way also to check things. And if we go back up to number 2, let me change colors here. I could, instead of saying 9 here, I could have just said H and then seen when I get one of my, and put in different values, but that, or go up and down. Let me show you what I mean. I can arrow up and down, but that would have been tedious, but it could have been done. Okay, so let me go back and clear. Okay, I'm going to clear everything out. So let me put in my formula and then arrow up and down and see what happens here. Okay, so of course I am not including pi. Pi is just hanging out like a variable, okay? I'm just looking to match the coefficients. And B of one, my option B for number 2, 147 was what I needed, okay? So I'm going to set up my fraction, and then I'll say 7 squared x, okay? Remember, instead of 9, I'm going to type in x, okay? And then 3 as my denominator. Enter, and I'm going to use my ask, not my ask, my list, sorry. ask won't work because I'm not looking for the value of X. I'm looking when I get the right Y value. Let me show you. Okay, well, I'm arrowing down here. I know that X needs to be 9, but as I go down, I'm going to see I have 49. Well, obviously 3 isn't going to be acceptable because I need a value of 109 or actually 108 or higher. So let me keep arrowing down with the positives. Okay, let me get a whole number. 98, no, I keep going. Okay, 9 yields 147. That is what we have, B. And I keep going, and then it gives me 196. Well, that's not even a good option. And then I get 240, 245, and it's too high. That's one way to get there or to verify, but you have to know what you're doing. The traditional method that we used was perfectly fine. Okay, now that I've kind of played around with the calculator for you, let's move on. Number 4, if a cube has a volume of 350 inches cubed, what is the total surface area of the cube? Well, we all know that the surface area of a cube is equal to 6 sides, 6 faces, and each face is side squared because the sides are equal, right? So it's side times side, right? Okay, but we need to know what S is. Well, we can get that very quickly. We have the volume. Well, what does volume equal? Well, volume equals side to the third because the volume would be side times side times side. Okay, and we know that equals 350. So what do? We cube both sides, and this will give us S is equal to the cubed root of 350. Now, we take this value and simply substitute it in here. Okay? So we have 6 parentheses, and I want you to do second, pair it up, type in the cube we need, which is 3, and then the 350. This will get our S for us. 350, arrow over, and I want you to square that. Close your parentheses, push enter, and now we have the value we need with a little bit of rounding. It's option B. Okay? All right. Now let's go to number 5. Find the total surface area of a square pyramid whose base has a side of 6 and a perpendicular height of 4. Well, perpendicular height is that squared height here that I was talking about before. That will be the number 4 here. Okay? And I could actually let's just change colors because we got a lot of pink and blue going on. So this will be 4. And then it says this is 6, each of our sides, because it's square, right? It's a regular square side. Well, now, if this is 6, if each side is 6, then our blue right triangle, we would know then that's 3. So we'd have like it's not a radius, but we know that the smaller leg of our triangle is 3. The taller leg is our height, which is 4. Well, this is a 3, 4, 5 right triangle, which is the smallest primitive triangle. So I know that this slant height here is 5. And I need to know that, okay? Because what we need is to add the 4 triangles, which are the lateral surface area, because it's asking for total surface area. Okay, so I need 4 triangles. All right, so let me write this down. I need 4 triangles. Okay, and I know each of those triangles is base times height divided by 2. Okay, so I'm going to divide by 2. All right. And then my base is 6, base times height. Well, we can't use the 4. That height is the perpendicular or what some laymanly called the square height, right? Okay. The 4 is going up the middle, and that's for volume. We want the slant height, which is the 5. Okay. So we need to say base times height. Okay. So it's 6 times 5 divided by 2, and there are 4 of them. However, we have something missing. That's just the lateral. Now we need the area of the base. Okay. Okay, so that's 6 times 6, right? So that's 6 squared. So let's put it all together and see what happens, right? So we have 4, and then I'm going to clear everything so you can really see it. 4 parentheses, set up my fraction, 6 times 5, arrow down. Okay, now that's 4 triangles, 1, 2, 3, 4 around the top. Okay, and then I'm going to add the bottom, and that is 6 times 6, which is 6 squared. Press enter, and I obtain 96, and that is correct. That would be B again. Okay, all right. Now, if you're not sure about this, you need to look at what we call a net. Okay, so a net would be the base, and then you would draw each. Oops, let me do this a little better here. Each of the triangles would go out like this. Okay. All right. That would be the net. And then now, again, pretend like I can draw this. The height of each of the triangles, that is the 5. Now, you may have said, wait a minute, you got that 5 pretty quick because I told you it was a 3, 4, 5 triangle. Well, you could stop the video and check this for yourself, but let's do it really quick. Well, how do we know what the hypotenuse of the blue triangle is? Well, second, under the radical, we need 4 squared plus 3 squared. Press enter, and that is 5. Okay, all right, going on to number 6. Okay. If a ball has a diameter of 3 meters, what is the surface area of the ball? Now, that is on your formula sheet, and we know the surface area is 4 pi r squared. And if you care or it matters, you can take the first derivative of the formula for volume and you will derive this formula. The first derivative of the formula is the surface area. Anyway, that's a calculus thing you learn. If you haven't had calculus, don't worry about it. It's fine. But I do need to make a point here. All of our answers, they're all in terms of pi. That means pi here is going to go along for the ride. So what do we put in our calculator? Well, we put in 4, and then we need the diameter is 3 meters. Do we use a diameter? No, we do not. But you could do this because pi's hanging out. So we need 4 times what? Half the diameter, right? And then we square it. We'll just do this. If it's a big number and you, oh, sorry about that. Let me clear it out. 4 parentheses is probably best because we're talking order of operations and the calculator does what you just saw. So put your fraction in. What do we need? We need 3 divided by 2. That's diameter divided by 2 is radius. And then you go over and we need to square our radius. So now you can push square, parentheses, press enter, and 9 is what we need, which again would be option B. And by the way, that's a coincidence. Don't, definitely quinkety. Don't just push B on all your answers when you take your test. I promise you it will not work, okay? This is just a coincidence and it happens to be the way this manual was written, okay? All right, this is the last problem in this video. I wanted to thank you so much for all the kind comments and all your successes. Awesome, guys. You're messaging me and telling me that you passed the test. Kudos to you. You are amazing. And remember, you're the one that took the time to watch the videos and practice. It's not on me. You know, you guys are thanking me, and I appreciate the thank you. But remember, it takes time to study and time to pick through these videos. And if you've done that, Give yourself a big kudos and pat on the back. Thank you for sharing, liking, and subscribing. Thank you for subscribing. Happy testing, everyone.